start, several different designs were taken into consideration and the best one was chosen. The design of the chosen drill was then started by reverse engineering the handle, where a two-part mold was created. Air drying clay was used to construct the mold to ensure that the mold maintained its integrity after being pulled off the driller. To ensure the cast maintained integrity after being pulled from the driller, fiberglass resin was used with sufficient amount of hardener. The cast was sanded and filler was used to correct any pores in the mold. Finally, the cast was given one clear coat of white paint. This was required to get an accurate reading from the 3D scanner. The cast mold was then taken to be 3D scanned. The cast was then placed in a Roland LPX-250 3D scanner. Rotary scanning with a 0.2 cm resolution was used to generate a virtual three-dimensional object. The three-dimensional object was then analyzed using the Pixar3 software, where corrections were also made to the 3D scan itself. The three-dimensional object was eventually converted to mesh to make it usable in Autodesk Inventor. The model generation of the cordless drill was then continued by splitting the drill into upper and lower components. A vernier caliper was used to measure the required dimensions to generate said models. One such dimensional model, that of the drill chuck, was also created in order to use a three-dimensional printer to generate a physical representation of such a component making up the cordless drill. The remaining components that made up the cordless driller were then measured, generated, and assembled to create the three-dimensional representation of the driller as shown.